The general idea of the fundamental theorem of calculus is actually pretty cool. Let's see what it says. Essentially what it says is differentiation undoes integration, and vice versa. Integration undoes differentiation. And actually this works out in a pretty neat way if we look at the processes involved in how we came up with differentiation and how we came up with integration. Let's look at differentiation first. F prime of x, remember that's the derivative, is equal to, and we defined it using this difference quotient, f of x plus h minus f of x over h, and then we took the limit. Let's think about the operations that we need to do to calculate the derivative. So we have 2 points, x plus h and x, and once we have those, we evaluate the functions, and the first operation that we use is actually that subtraction. We subtract to find out how much y has changed. That's the first operation. After we've done that subtraction, the next operation is divide. So that is, we divide the change in y, f of x plus h minus f of x, divided by our little increment in x, h. So that subtraction finds how much it changes, dividing finds the rate. Subtraction finds the change, dividing finds the rate. That gives us the rate of change. And then finally we take the limit to get the actual derivative, or the instantaneous rate of change. Subtraction, division, take the limit. That's a derivative. When you see derivative, think subtraction and division. When you see subtraction and division, think derivative. Integration, on the other hand, we defined this thing we called the accumulation function, and that was equal to this integral. It was the integral from a to x here is the variable. I'll use the integrand to be g of t dt. Remember how we came up with what this integral was. We said that that's equal to this sum. It's equal to the limit of this sum. And the sum, what are the operations involved? Well, the first thing we did was we multiplied. Our first operation was multiplication. That is, we multiplied the width times the height. Remember, that gave us the area of one small rectangle. So the first operation was multiplication. What's the next thing we do? The next thing we do is we add them all up. So the next operation is to add a whole bunch of things together, and then finally we take a limit. That's fundamentally what integration is. It's multiplication and addition. When you see integration, think multiplication and addition. When you see multiplication and addition, you think integration. Now, what would happen if we first did a derivative, and then we took the result of the derivative and integrated it? That is, what if we took this f prime of x, and we stuffed it in here to get the integral? Well, what were the processes? We would start with a function, we would subtract, divide, and take the limit, and then we would take the result, multiply, add, and take the limit. So disregarding taking the limits for just a second, subtraction, division, multiplication. Well, that multiplication could undo that division, and in fact it does. So the multiplication and divisions would cancel out, and then this addition would undo the subtraction. So the addition and subtraction would cancel out, and we might get back what we started with. We start with f, take the derivative, integrate, get back to what we started with. And that's in fact true up to a constant. It turns out that taking the limits actually makes everything work out nicer. So instead of getting in the way, it'll actually turn out that they make things work out nice. It works vice versa too. If we start with an integration, if we start by finding this accumulation function, well, we would start with a function g, we would multiply, we would add things up, take the limit, that would give us that. Now if we take this accumulation function over here, and we take the derivative of it, the first thing we would do is subtract. That subtraction would undo that addition. And then we would divide. Since the subtraction undid the addition, what would be left is that the division would undo the multiplication. And we would be back to exactly what we started with. That'll turn out to work out exactly when we throw in the limits. The derivative of a will be exactly what we started with, g. That's the idea, the general idea of the fundamental theorem of calculus. Differentiation undoes integration, because subtraction and division undoes multiplication and addition, and vice versa.